We're talking today about more binomials, and they call it special cases. How many of you on your homework, you didn't do as well as you wanted to? Like you thought you did well, and then you looked at your homework and like, oh man, I missed a lot. How many of you didn't do as well as you thought? 2 of you, 3 of you, wow. How many of you did better than you thought or as well as you thought? Like, yes, I knew I got them all, and I got them all. Okay, how many of you, you were just kind of in the middle, didn't do as well, but didn't do as poorly as you could have? Okay, how many of you didn't vote? Awesome. I had a girl in my previous school, 9th grade. She's like, Mr. A, she came up to me one day. She said, Mr. A, I never vote when you ask. I'm like, oh, that's too bad. So the next time I asked her to vote, I'm like, how many of you like this? How many of you like that? Guess who didn't raise her hand? That girl. I said, how many of you never vote? And she proudly raises her hand. I never vote. Like, thanks for your vote. Okay, so I broke her streak of never voting. So, yeah, what voting does, honestly, it helps me. Because if I say, all right, how many of you struggle with this lesson? And one of you raise your hand, what do I think? The rest of you did pretty well, right? It's an easy lesson. So I'm like, I'm not going to spend as much time because you got it. If you all raise your hand, I'm thinking, oh my, we got to work on this more. But do you see how it communicates to me something I probably need to know? So please vote. Not only when you can, when you're older, but even here when I ask you to, because that helps me out. Okay, but anyway, this is called more binomials. So go ahead and write this problem if you haven't already. This is stated x plus 2 squared. Okay, x plus 2 squared. Does anyone know how to rewrite this problem using multiplication? I just want to write a multiplication problem. Like, how do you even know that? Well, there's a little square there, so that tells me I can rewrite it. Okay, Philip?
X squared plus 2 squared?
Okay, it seems like that, but it's not that simple. It really isn't that simple. You'll see when we actually work it out.
X plus 2 times x plus 2?
Yeah, it means x plus 2 times x plus 2. That's what it means. It means that x plus 2 is used as a factor twice. Factor, factor. That's what it actually means. And does this look familiar to any of you? You did this a lot for yesterday's homework. So this is what we're going to be dealing with today. But these are special cases. That means there's something special about when you work them out. And I'll get to that in a moment. But what we're going to do here is we're going to practice all 4 methods. But I'm going to focus on distributive and FOIL. Those are the ones I really want you to get down, but we're going to practice all 4. So the first method we're going to use, as you probably saw, tabular method. I know, it's horrible to draw these rectangles. Okay, and we're going to use this multiplication problem to fill in the spots for the tabular method. So which one should I put up top?
X plus 2.
Nice. Hope you didn't get that one wrong. And then x plus 2 on the side. Okay, so I got my x plus 2.
Does it matter which one goes on the top and side with other problems?
Great question. Who has an answer? Does it matter, like let's say x plus 2, x plus 3, does it matter which one goes where? No, because of the commutative property. If these two are being multiplied, you can flip them around. Okay, so does that answer it? Yeah, and so you're allowed to do that. In this case, you have no choice. All right. Hagen, what's x times x? X times x. X squared. Michelle, what's x times 2? 2x. Jackson, what's 2 times x? 2x. And then Eva, what's 2 times 2? 4. Okay, so that's how you get those individuals. And again, if you wrote in standard form to start off with, you got like terms right there. So it's 2x plus 2x, 4x, and then you get your final answer of x squared plus 4x plus 4. That is your answer right there. Pretty straightforward, and that's tabular method. And you don't have to use it for every problem, but you have to be able to know how to use it. So here's another practice one. Any questions on tabular? Okay, do you notice anything on tabular in this particular problem? Do you notice that 2x is in 2 spots? Do you notice that? 2x is in 2 spots. So it's the same for both of those. Okay, keep that in mind. Let's move on. All right, I got x plus 8 squared. How can I rewrite that with multiplication? Drew? x plus 8 times x plus 8. That's what it actually means. So we're not using tabular on this one. We're going to use, what's the second one? Okay, vertical. Someone's like, no, I want to get to FOIL. No, vertical for this one. We'll get to FOIL soon. So the vertical format, you're going to stack these two together on top of one another vertically. And I'm going to put this little x here with multiplication. And I need to put in parentheses so I'm not confused. In fact, in Algebra 1, I just noticed this here. In Algebra 1, they're going to be doing division of polynomials. And you're not going to do it the way they're going to do it this year. You're not going to do it this year the way they're doing it this year. But you do need to know, you need to make sure you write what operation you're doing, because if not, you can mix things up. You can say, oh, you're just adding or just subtracting. No, you are multiplying. Who remembers how to use a vertical format? Okay, okay, Alex. So what do I multiply first?
8 times 8.
8 times 8 is positive 64. Okay, 8 times 8 is positive 64. You just multiplied. All right, and then Alex?
And then 8 times x.
8 times x is?
8x.
8x. So nice and easy on that one. That's your first partial product. Okay, who else knows how to do vertical multiplication? Josiah, what would I do next? X by the 8 gives me positive 8x. Now, why did I leave a blank here? 2 reasons. Somebody? 2 reasons. 2 reasons. Jack?
Placeholder.
Placeholder?
And because they're not
L-I-K-E. Like terms. So you want to stack like terms, you keep it like this. Okay, great. And then, sorry, Josiah, next. X times x is x squared. You got 2 partial products, and you are adding them together. You're adding this partial product with this partial product, and you get your final answer of x squared plus 16x plus 64. There you go. That's your final answer on the vertical format. Now, can I have you notice something else? Do you notice that you got the same term twice? Okay. Keep that in mind because it's coming up. Any questions on vertical? How many of you know how to do vertical? If I told you do them all vertical, you could do it. Or do them all vertically, you could do them all vertically. All right. But you don't have to do that. All right. This one's different. 2m minus 9. But how do you write that as a multiplication problem? Mary.
You do 0 and minus 9, and then you do it again.
And then you write it again because they're being multiplied by each other. All right, so 2m minus 9 times 2m minus 9. What's the third method we looked at yesterday? Distributive. How many of you like distributive? There you go. Good. That's what I thought. Okay, how many of you hate it? Going to have a hard time this year? Okay. You actually love it, don't you? You meant you love it. No? All right, Mary. All right. Okay. Who could do it? Distributive property. Who could do it with distributive property? Who's comfortable? All right, Andrew, what do you do first? 2m times 2m is what?
4m.
4m squared. So you just multiply 2m times 2m. All right, and then next, Andrew?
2m times negative 9.
2m times negative 9, which is negative 18m. Okay, that's your first distribution. Someone else who knows how to do distribution or distributive method here. Philip, what would you do next?
Negative 9 times 2m would be another negative 18m.
Negative 18m.
And then negative 9 times negative 9 would be positive 81.
Good, positive 81. Don't forget your signs. 2 negatives multiplied together get me a positive. Always. That's always the case. And then do I have like terms? Yep. So I get my final answer of 4m squared minus, or you can say plus negative 36m plus 81. That's your final answer. Yay, distributive property. Okay, do you notice on this problem that you have 2 terms that are exactly the same? Okay. Sorry? Close. There's something, I think some of you might be thinking of it, but I'm going to clarify it here. Okay, this is what I want you to write. Write square of a binomial. That's the first special case. This is the first special case. There are two. And we've done it now 3 times. And I was debating with the last class, like in my mind I was debating, should I teach them this or should I just hold back? And I thought, you know what? They're ready. And guess who's ready today? You are. Make sure you're not distracted by anything. And let's get ready for square of a binomial. Okay, I got a plus b squared. That's the square of a binomial. Okay, this is a binomial. That's squaring it. So that means there's got to be a shortcut to multiplying these out. Okay, ready? Here's a shortcut. And I'm going to put it with this binomial squared, and then I'll give you some actual problems, and you'll see, oh, wait, that is what you do. Okay, ready? To get the answer, directly to the answer, what's a squared? Or what's a times a? This is a squared. That's the first term of your answer. Automatically. Boom, you got it. That's your answer. A squared so far. There's 2 more terms. The last term is going to be b times b, which is b squared, and it's positive b squared. Now all I have to do is find that middle term. And the middle term, I'm going to write it down. Some of you are going to be like, huh? And then I'm going to show you how we got that from the other problems. But this is how you find out that middle term. What's a times b? AB. What's twice AB?
AB squared.
Twice AB. 2AB. That's twice AB. That's the shortcut. What? That's not a shortcut. I don't even understand the short or the cut part of that. Okay. Let's get some numbers with this one so you can actually see it. Did we do 3x plus 4 squared? Is that one of the problems we've done already? 3x plus 4 squared. No? Okay, we'll do that one. 3x plus 4 squared. Okay? You can use tabular, vertical, distributive, and then even 4, which you haven't touched on yet. Or you could do the shortcut. Is this a square of a binomial? Is this a square of a binomial? Yes. Go directly to the shortcut. Ready? What's 3x times 3x? 9x squared. That's your first term. That's your answer. Part of it. What's your last term? Well, what's positive 4 times positive 4?
16.
Positive 16. Yay, positive 16. And the middle term is the hardest one out of these because it's hard to compute, but let's see if you can get it. What's 3x times 4? 12x. What's double 12x?
24x to the second.
Positive 24x. That's your answer. So I did ask the question, how many of you don't like any of the methods or distributive property? I mean, if you really don't like distributive property, here's your chance not to use it. Dare I say it. But I'm going to say this. If you don't understand this shortcut, just do 3x plus 4 times 3x plus 4 and use whatever method you can. You'll still get that answer. Does it work for problems like these? Wow. Okay, let's go with n minus 11 squared. N minus 11 squared. Okay, is that the square of a binomial? So is this a binomial and is it being squared? Yes, you go to the shortcut. Go directly to the shortcut. Okay, who knows what the first term would be? What do you think it'd be? N squared. It's just n times n squared. All right, Alex, what would be the last term?
102.
Close.
Wait, 141.
Yeah, positive 121. Because what's negative 11 times negative 11? Positive 121. So you got to know your math facts there, and you got to know what 11 times 11 is, which is tough sometimes. What's the middle term? Because that's the hardest one. Well, what's n times negative 11? Negative 11n. What's double that? Negative 22n. Done. Shortcut. How many of you like shortcuts? I know some of you love it. You're like, Mr. I wish everything had a shortcut. Well, here's your chance for this one. How many of you get the shortcut? How many of you don't get the shortcut? Okay, if you get the shortcut, use it. What happens, Mr. I forgot what I don't know what you're saying. I don't even get any of that. So how do you figure this one out? You just do n minus 11 times n minus 11 and use your preferred method. All right. I know I keep asking this, but did you guys do x plus 8 yet? Squared? X plus 8 squared?
Yes.
I think you did. Okay. Let's do 6y plus 1 squared. You do that one yet? All right, do that one. 6 plus y squared. And I'm going to have to, I think I added this. Yeah. This is your problem. Yep. 6. I don't know what I was saying, but it should be 6y plus 1 squared. I'm sorry if I said something different. That's the problem. Sorry. Forgive me. Don't hurt me. Swivel, protect me. See, they say cameras can't protect you from danger, but they can record what happened and help you in the court of law. So I'm still going to get hurt maybe, but at least I know who did it. So don't hurt me, please. Who knows the shortcut? A couple of you? All right, 3 of you. Who doesn't know the shortcut? So you need to work it out, and that's okay. Either way is okay. There's a pro and con to knowing the shortcut. The pro is that it's very short and easy. It is. It's short and easy. It's good. The con is that you use the shortcut maybe when you weren't supposed to. Like it didn't apply. So make sure you use the shortcut when it's allowed. Is this the square of a binomial? Is this the square of a binomial? Yeah, so you can use a shortcut. But if not, that's okay. All right, who has an answer? I don't care how you did it. Sam?
36y or 36y squared plus 12y plus 1.
Yes, that's the answer. So how many of you did it 6y plus 1 times 6y plus 1? You did like FOIL or distributive or vertical or tabular, okay? How many of you did the shortcut? Did anyone do the shortcut and not get it? Maybe like miss something? It's okay. Do you know what you missed? What did you get? When you did it?
I don't know how, but 36y squared.
Awesome. Keep going.
36y squared plus 1.
Oh, okay. So you did the 6 squared, 6y times 6y. You did the 1 times 1, but you got to do the 6y times 1 doubled to get that middle term. So you forget that last term. All right. So again, you don't have to use this method, but you can. All right, let's look at another one.
Can we now use it now?
So you can use the method for that.
Okay. Is this the square of a binomial?
No.
It's x and 7 there. There's a critical key difference. Difference. The variables are x, the numbers are 7s, but what's happening between these two? Addition. What's happening between these two? Subtraction. Can you make this any simpler? Can you write it like x plus 7 squared? No. Can you write x minus 7 squared? It is not the square of a binomial. Please don't use a shortcut on that because it's not there. You'll get something else and you're like, oops. Okay, let's use FOIL because we haven't used FOIL yet. And again, I do this for you guys in your notes. You don't have to write it all out like this on your homework. All right, FOIL. All right, who's good with FOIL?
Isn't it the same thing?
Yep. But who's good with FOIL? Yeah, you can do either way. I'm good with both. Who's good with FOIL? 2 of you. 3. Okay. Anna Grace, what are the first terms?
X and X.
What's x times x?
X squared.
All right, so that's the first term. Who knows the outer terms? What are the outside terms? Philip?
X and negative 7.
What's x times negative 7?
Negative 7.
All right, great. What are the inner terms? 7 and x. What's 7 times x? Positive 7x. And what are the last terms of each binomial? 7 and negative 7 give me negative 49. Great. All right, adding like terms. What do you have?
X squared.
Oh, sorry, adding like terms, what do you get? What are like terms, if any? What are these two added together? Be careful.
0.
0. So they cancel out. So what are you left with? X squared minus 49. Answer is complete. Did you guys remember on your homework, one of your answers was like x squared minus 100? That was that problem. It was this kind of problem, just had 10 and 10. So the same problem. That's your answer. All right. Do this one. Do it anyway. Whatever it takes to get it. How many of you are going to use tabular method? You're going to use the table, right? How many of you are going to use vertical method? Vertical method. How many of you are going to use distributive property? How many of you are going to use FOIL? How many of you are not going to do it? Oh, wow. More votes than... Okay. Go ahead and get it done anyway. Is this a square of a binomial problem? Is this a square of a binomial problem?
No.
No. There's no square because these two binomials are different. They're not the same. Okay. My turn. How many of you... Oh, no, I already asked that. Sophie, what's 3x times 3x?
9x squared.
9x squared. That's f in FOIL or the first distribution multiplication. Jack, what's 3x times negative 10? Negative 30x. Okay. Darius, what is 10 times 3x?
30x.
Positive 30x. And then what is Matthew 10 times negative 10? Negative 100. All right. Like terms, are there any? Mm-hmm. Yep, these two. What do these two combine to give me?
0.
Oh, 0 again. That's nice. 9x squared minus 100. Huh, that's kind of cool. Didn't these cancel out in the last problem?
Yep.
Last one on your own. Do this last one on your own. Be careful, R and S. Use any method. I mean, no one's using tabular? No one?
No.
Okay, sorry, Andrew, you're right. One person in the other class also used tabular. One. All right, vertical? Vertical? Okay, I think 3 of them used it in the other class. This, you would, but not this one. All right, what about vertical? Vertical? 1? None over there. Distributive? It's same as that. FOIL? Yeah, and that's the same split as the other one. Man, you guys prefer distributive and FOIL. Oh, wait, I mean distributive. I meant FOIL. Get those mixed up. All right, here we go. Brad, what's 5r times 5r?
25r squared.
25r squared. Lana, what's 5r times negative 6s?
Negative 30s.
S
Sorry.
R.
Yeah.
Mm-hmm. Or RS, same thing. Hudson, what is 6s times 5r?
30 SR.
Okay, 30 R SR. You were going to say, kind of like I just said, you were going to say RS. What if you did this? You got SR on one and RS on the other.
Weird.
Are they still like terms?
Yes.
Yes, because of which property you could switch those around? Commutative. And so what's the definition of like terms? Same variables with the same exponents, even if they're switched around. But you guys picked SR. And then last, William, what's 6s times negative 6s?
Negative 36s squared.
Negative 36s squared. Great. All right, what happens with those two middle terms? cancel out, and you're left with 25r squared minus 36s squared. Final answer. Okay, is this the square of a binomial? No. But is there a shortcut?
Yeah.
And I'm going to rewrite this. It is, go ahead and write this, the difference of two squares. That's what it's called, the difference of two squares. And then write a plus b times a minus b. Again, I'm trying to say this so you can get drilled in your head. This is not square of a binomial. It is the difference of two squares. They're not the same. Because if they were the same, we'd be done a long time ago. Okay. Notice you have a binomial where you have addition and a binomial where you have subtraction. Interesting. Dear, I can't read that name, but I'll continue. I can't believe it's been a week since we last talked. Uh-oh. I won't reveal any names. You filled in the blank. It was invisible. No, okay, you guys are good. As long as you're not passing notes. Are you ready for homework?
Yes.
Are you sure about that?
Yes.
No.
Uh-oh. Okay. So I hope you guys are... There was nothing written on that paper. I don't think. Unless this is invisible ink. But let's keep going here. It's the difference of two squares. You have a binomial with addition and a binomial with subtraction, and these could be flipped. That's okay to get flipped. The answer would be a times a, which is a squared, minus b times b, which is b squared. That's your answer. That's how you get it. You multiply these two, get that number. You multiply these two, get that number, and there's always subtraction. You know why we call it a difference of two squares? Here's the secret.
Subtraction.
There's a difference of two squares. That's why we call it that. I know. That's deep. That's deep. Okay, let's see if you guys can do this one. Oh, I don't know about this one. This one's tough. All right. X plus 12 times x minus 12 equals, don't say it out loud, just get it. You can use a shortcut if you're like, Mr. Ed, I don't know the shortcut. Then do FOIL or distributive. It's a difference of two squares. You know that.
Squares?
Squares. And you're like, why do they use the word squares? Because what do you think of when I just say, draw me a square? You're thinking of something like that, right?
Perfect.
But guys, the squares are right here. How do you find the area of a square? You multiply the length by the width, right? Which are the same thing, which always gives you a squared. The other square is right here. B times b is b squared. It's a difference of two squares. Geometry is going to show that up a lot more, but... All right, what's the answer? Hagen.
X squared minus 184.
Done. That's the answer. That's it. Listen to me carefully. You can use the shortcuts if you can identify the difference of two squares or the square of a binomial, and if you know how to do that. But if you don't, like you come tonight and you're like working on this and you're like, oh man, I totally forgot. Just multiply them out using your four methods, one of your four methods, okay? That's there for help. All right, your homework. Yes, it's that time. 14 to 28 even. You want more? Okay, so 14 to 28 even, and that's pages 153, 154.